Hey there, got a short little video here for you about complex numbers. This is an introduction to what they are and what we do with them. Our goals for today are to be able to simplify radicals as well as to understand and apply the powers of I. So when we talk about radicals, we often leave answers in radical form because it is more exact. When we square root something, we get a decimal and we end up rounding. That can sometimes cause some round off error. So in math, we often leave our answers in radical form because it's an exactly correct answer. However, radicals must be simplified. So you cannot leave them in radical form if there is um, a square root that you can take out. So when we simplify radicals, we make a factor. So I'm going to make a factor tree for 75. I know that that's 3 times 25, and then I know that 25 is 5 times 5. Okay, hope you remember this from like 4th or 5th grade. But we make that factor tree, and then what we do is we look for pairs. So here I have a pair of 5. The pair comes outside of the radical and becomes the multiplier. The leftover stays inside. So this becomes, the square root of 75 becomes 5 square root of 3. I have now simplified that, and I'm okay to move on. Notice when I'm simplifying, I'm only looking at the ends of the tree. I'm not looking at any of the branches. That 25 doesn't matter because it's a branch. We only look at the ends, or the roots, if you will, of the radical. So let's try 24. I'm going to start by making a factor tree. I know that 24 is 8 times 3. I know that 8 is 4 times 2, and I know that 4 is 2 times 2. Notice I just keep breaking down the numbers until I can't go any farther. Now I've got a 2, 2, 2, 3. I'm going to look for a pair, which I have right here, which is a 2. Now this time I have 2 leftovers. I have a 2 and a 3 left over, which I multiply to get 6 inside the radical. So when we're simplifying radicals, again, we're making a factor tree. We're looking for pairs. Pairs get to come out, and the leftovers get to stay inside. This is important because sometimes we end up with a negative radical, and we have to use an imaginary number to help us simplify that. Now, they are called imaginary not because they are in our imaginations, but because they do not exist on the coordinate plane. They do exist in other planes, just not on the coordinate plane that we're used to dealing with. So don't think that, oh, they're imaginary, I don't have to do anything with it. That's not the case. You do have to simplify using I for imaginary units. And the square root of 1 is 1I. Okay, so when we're simplifying, we just divide the negative 1 out and then simplify the positive number that's left. So let's work through a couple of these so you can hopefully see that. So here I've got the square root of negative 16. The first thing I want to do is separate that negative out. I'm going to separate this into the square root of negative 1 times the square root of positive 16. All I did was take that negative 1 and separate it out, okay? Because I know that the square root of negative 1 is an I. And I know that the square root of 16 is 4. Now I can simplify this to be 4I. Okay, stop and think about that for a second. Do you see what I did there? I separated the negative 1 out of the radical so that I can use an I, and then I simplified the positive radical that was left. So let's try this with the square root of negative 25. I'm going to break it apart into the square root of negative 1 times the square root of positive 25. I know that square root of negative 1 is an I, and the square root of 25 is 5, which gives me 5I. I would expect as you get more comfortable with this, you don't have to show all the work for that, but I'm showing you the different steps so that you can kind of organize it in your mind and understand what we're doing. Now those worked out pretty nicely. 48 doesn't have a square root, so what do we do then? Well, first we separate it, negative 1, positive 48, okay? That gives me an I here. Now for 48, I'm just going to make a factor tree like I did previously, okay? So I know that's 6 times 8, this is 3 times 2, this is 2 times 4, and 4 is 2 times 2. Again, I'm looking for pairs. So I have a pair here, and I have a pair here. That gives me 2 2's outside, which is 4. And then the only thing I have left inside my square root is a 3. Now, remember I still have that I there, so I times 4 square root of 3 is 4I square root of 3. Okay, so I'm putting together a bunch of different pieces here of both simplifying the radical, using a square root of -1 to make an I, and I'm kind of all putting it together in one process. I hope that makes sense for you. I'm going to do the same thing with the square root of -13. I'm going to make it the square root of -1 times the square root of 13. I know this is an I. I also know 13 is prime, so it doesn't have really a factor tree. So I'm just going to leave it as I square root of 13. So simplify if you can. You don't have to if there's nothing to simplify. Leave it in radical form. Use that negative square root of -1 as an I. Now, when we talk about I, we also have to talk about the powers of I. So we're not always just dealing with a one I. Sometimes we have different powers of it. Let's talk about what this means. When you take the square root of -1 times the square root of -1, you're squaring that, right? So you are taking the square root of -1 squared. I'll think back, we talked about this a while ago, but a square and a square root cancel each other out, and you're just left with -1. The same is true for I times I. We get I squared, which is the same thing as the square root of -1 times the square root of -1, which we already know is -1. This comes into play when we start multiplying complex numbers, which we will be doing, or multiplying i's by each other. So, for example, when we have 2I squared, now I already know that I squared is equal to -1. So I'm just going to replace the I squared with what it's equal to, -1, and I'm going to simplify. Times 2 is -2. Okay, over here I'm going to have -7 times -1 because I squared is -1, which gives me a +7. I hope you're starting to see a little bit of a pattern here. Now this one, my square root is outside. So I'm going to take 5I times 5I, which is 25I squared. Can't leave that I squared. So I'm going to multiply 25 times -1, which is -25. Do you notice that each time we have an I squared, we're simply multiplying its coefficient by -1? Kind of makes this easy, right? So in the next one, when I multiply 4I times 7I, I have 28I squared, which is -28. 3I times I is 3I squared. -1 times 3, -3. So once you get the idea of I squared being -1, it becomes pretty easy to then just multiply that by the coefficient and change your sign, okay? So I squared, not super difficult. Just remember that it's equal to -1, and then you multiply that by whatever your coefficient is. Hope this makes sense for you. We are going to continue more with operations on complex numbers, and this I squared will be important for that. So make sure you really understand how to simplify a negative radical and how to use the powers of I to simplify as well. As always, this has been a production of Khan Alonso Inc. We are here to help you learn math concepts and hope that you are growing each day in your math knowledge. As always, have a wonderful day, and we'll see you soon.